Okay, lesson 2. This is the second method of 5 that we will technically learn, but again, the graphing is just so you can see the connection. So today we are going to solve quadratic equations by factoring, and so this goes back to Unit 7 and all the factoring that we just finished. Just to review, factor like you did in Unit 8. In this first problem, first thing I should always check for is a GCF. I can divide both of those by 2 and x. So if I do that, I'm left with x plus 5. And then since there's not a squared there and there's only 2 terms, I'm completely finished. Okay, for the second one, there's 3 terms. There's not a GCF here, so I'm going to go ahead right away and start with my x, my AC split. This is a 1 here, so I'm going to put my negative 48 on top. 1 times negative 48 is negative 48, and put my 2 on the bottom. And this is where most people struggle. I have 1 times 48, I have 2 times 24, I have 3 times 16, I have 4 times 12, and I have 6 times 8. Now, since this top number is negative and the bottom number is positive, I know that the smaller number of the 2 in the pair needs to be negative. So then this is the pair I'm using, so negative 6 and 8. Now, I'm going to show you one thing to speed this up. Since there is nothing in front of here, you could rewrite this as x squared minus 6x plus 8x minus 48 and make your 2 groups and factor from there. I'm going to show you a shortcut. If there's not a number out front, we can go directly to our parentheses using the 2 numbers that are off to the side. Okay, so these 2 numbers here, since there's nothing in front here, go directly to our parentheses. Okay, and if you're not sure and that's too much, go back to the same process, make your 2 groups and go from there. Okay, next one, again, 3 terms, no GCF. So 1 times negative 24 is negative 24. Negative 10 goes on the bottom. Factors of 24 are 1 times 24, 2 times 12, 3 times 8, and 4 times 6. This time, the top is negative and the bottom is negative, so that means the bigger number has to be negative. If the top is positive, then they both have the same signs. So be careful because a lot of people will choose 4 and 6, but it's actually 2 and negative 12 because of those signs. And again, I don't have a number in front here, right there. So I'm going to go directly to my parentheses using those 2 numbers that we just found. So I'm going to write this as x plus 2 times x minus 12. Okay, and again, that only works when there's nothing in front of your x squared. Okay, for our last one, same idea here, 3 terms, no GCF, let's make our x. 7 times negative 3 this time is negative 21, and a negative 4 goes on the bottom. So 21 is 1 times 21 or 3 times 7. There aren't many options there. The top number is negative, so I know I have to have 1 negative. Since the bottom number is negative, I know it's the bigger number, and I'm going to use 3 and negative 7. So because there is a number in front of our x squared, there's a coefficient there, I can't do what I did on the last 2. I actually have to go through this whole process and rewrite this with our AC split or AC split B. So A and C stay the same. We're going to split B in the middle with our 2 numbers that we found on our x. So just remember, mark that up. Just remember that these 2 numbers are what we're using right here, just throwing an m in with them and going from there. So make our 2 groups. Watch that negative sign because it is important. In the first group, I can only take out an m, so I'm left with 7m plus 3. Second group, I can only take out a negative 1, so I'm left with 7m plus 3. Sorry about that. And if those 2 groups match, we're good. If they don't, we made a mistake. So I'm going to pull that 7m plus 3, and m minus 1 goes in the second group. Okay, zero the function. We talked about a 0 is going to be a solution that actually corresponds to when y equals 0, or an x-intercept. Okay, What the zero product property says is if I multiply two things, for example, A times B, that means either A has to equal 0, B has to equal 0, or both would be true. Okay, so using that for quadratics, we are going to solve these. So using the zero product property, if I'm multiplying this times this and I get 0, that means I know x plus 4 has to equal 0, or x minus 6 has to equal 0, or both. So if I solve this like we did back at the beginning of last year, I'm going to subtract 4 from both sides, I get negative 4. And I'm going to add 6 to both sides to get positive 6. I'm just going to put a comma to separate the two answers. Do not put parentheses around these. This is not an ordered pair. These are two different x-intercepts. For the next one, I am multiplying two things, x and x minus 8. So I'm going to do x equals 0, which I can't solve. I have my solution there. And x minus 8 equals 0. So if I add 8 to both sides, I get x equals 0 for the first one and positive 8 for the second one. Okay. Notice in the directions it does say no decimals, so be careful. Again, multiplying two things, so I'm going to set each of those equal to 0. Okay, I'm going to subtract 8 from both sides to get 2x equals negative 8, and then divide by 2 on both sides to get x equals negative 4 for that first one. For the second one, I'm going to add 1 to both sides to get 3x equals 1, and then divide by 3 to get x equals 1/3. Again, if you type this in, you would get negative 3 repeating, positive 3 repeating, but you are not allowed to have decimals there, so make sure you put that fraction in. Okay, last one. Again, setting these two each equal to 0, so 5x minus 4 equals 0, and 6x plus 2 equals 0. So we're going to add 4 to both sides to get 5x equals 4, and then divide by 5 on both sides to get x equals, it's 0.8. I don't want the decimal, I want the fraction. And then subtract 2 from both sides to get 6x equals negative 2, and then divide by 6 to get, this is negative 0.3 repeating, which is actually negative 1/3. And all I had to do for that is divide each of those by 2 to reduce. So that's how I'm getting my 1 and my 3. Okay, so we're going to take the factoring and the zero product property and put them together. So if the quadratic equation is not yet in factored form, you have to factor first. Then you're going to set it equal to 0 and solve using the zero product property. Okay, and actually you should make sure it's equal to 0 first. 5 problems. Okay, get ready. First problem. Okay, first thing, we need to make sure we have an equal 0 here. If we don't, we need to make sure we get an equal 0 there, and we'll talk about that with the last example. Second step, is there a GCF? There's not, so I'm going to go ahead and make my x right away. And I have a 1 times a negative 28, which is negative 28. And then the negative 3 goes on the bottom. So I need the numbers that multiply to give me 28 and add up to 3. But because that's a negative 28 in the top and a negative 3 on the bottom, I know the bigger number has to be negative. So that would lead me to 4 and negative 7. Because there's not a coefficient here, you can use that shortcut I mentioned in the warm-up problems and go straight to x plus 4 times x minus 7 equals 0. And then you need to continue on and solve by setting each group equal to 0. So we're going to subtract 4 from both sides to get negative 4. And we're going to add 7 to both sides to get positive 7. Now to check this, you could type those back into your calculator and plug them into this and make sure you get 0. So you could do negative 4 squared minus 3 times negative 4 minus 28. If you get 0, you're good. Same thing with the 7, and you're good. Okay, next problem. Again, first step, make sure we have an equal 0 here, which we do, so we're good. Second step, is there a GCF? In this case, there is not. Third step, there's 3 terms, so we're going to do x factor. I'm putting 35 on the top and 12 in the bottom. They're both positive, so both numbers will be positive. So I have 1 times 35 and 5 times 7. Those are my only 2 options. So we're going to go with 5 times 7, because that adds up to 12. And since there's not a number in front of my k squared here, I can go straight to my parentheses and use that shortcut. So I'm going to do k plus 5 times k plus 7 and set each part equal to 0. So k plus 5 equals 0, k plus 7 equals 0. Subtract 5 from both sides to get k equals negative 5, and subtract 7 from both sides to get k equals negative 7. Okay, again, you can check that by typing it in, plugging them back into the original equation to see if you actually get 0 for an answer. Okay, next 2. First step, make sure we have an equal 0. We do here, and we do here. Okay, second step, is there a GCF? In this problem here, there is not. So we're going to go ahead and go straight to our x and do this time 3 times 16, which is 48, and then put the 26 in the bottom. And I'm going to list out my factors. So 1 times 48, 2 times 24, 3 times 16, 4 times 12, and 6 times 8. And the 2 that we are going to use that add up to 26 are 2 and 24. I apologize, that looks like a 29 there. That's a 4. So I'm going to put 2 and 24 here. Now, because there's a number in front of my a squared, this time I have to use AC split. So we're going to go ahead and write out 3a squared. We're going to write out the 16. We're going to write 2a and 24a in between, and then equals 0. We have to make our 2 groups here. We can't take that shortcut because there is that number in front and find our GCF. So the first group I can only take out an a. So I'm left with 3a plus 2. The second group, I can divide both of those by 8. So I'm left with 3a plus 2. If those 2 groups match, we're in good shape. 3a plus 2 times a plus 8 equals 0, and then solve each of those. Apologize for that 0, that did not look like 1. And a plus 8 equals 0. So we're going to subtract 2 from both sides to get 3a equals negative 2, and divide by 3 on both sides to get a equals negative 2/3. Did not leave myself much room. And then subtract 8 from both sides to get negative 8. So my solutions are negative 2/3 and negative 8. Next one, same idea. We're going to go ahead and do a GCF if there is one, and in this case there is not. That is not what I wanted. Let's try drawing here. So 4 times 10 is 40. 13 goes in the bottom. So 1 times 40, 2 times 20, 4 times 10, and 5 times 8. 5 times 8 works. I'm going to go ahead and put 5 times 8 in there. Okay, and then because there is a number in front of my x squared, I am going to go ahead and try to get rid of these here. Not sure why they're moving. Okay, so we are going to go ahead and write this out using AC split. So I have 4x squared plus 5x plus 8x, and those are coming from my x over there, plus 10 equals 0. Let's make 2 groups and factor out our GCFs. So take out your x to get 4x plus 5, divide by 2 to get 4x plus 5, and then factor out that common group. So 4x plus 5 is in common, pulling it out front. X plus 2 is left over, and then solve each of those. So subtract 5 from both sides to get 4x equals negative 5, and then divide by 4. So my answer is negative 4/5 and -2. Final answer there. Okay, so last example, I know this video got kind of long because I went through the warm-up, but if we do not have an equal 0 here, I need to get an equal 0, so I need to cancel out that -5 by adding 5 to both sides. So I end up with 5x squared minus 3x minus 2 equals 0. And I'm actually going to leave that one for you to try and come back and check your solution when you're done. Here's your solution. If you have any questions, do not hesitate to ask. Go ahead and do your practice problems there, and then there is an additional practice set for 9.1 and 9.2 after this. So there's plenty of problems for you to do. And again, don't hesitate to speak up if you have any questions. Have a great day.